Hi, welcome to the world of chemistry. It's an exciting, colorful world. Things transform before our very eyes, and an imagination is a key to understanding chemistry, because chemistry is about atoms and molecules which we do not see, but we have to imagine them in order to understand why matter behaves the way that it does. Virtually everything you see, touch, and feel is made up of molecules and atoms. It's chemistry. Let's take some ice. Pour a little more. Ice is the solid state of water, and water is given the symbol H2O, meaning it's made up of 2 parts hydrogen and 1 part oxygen. A model of the water molecule can be shown here. The oxygen is red and the 2 hydrogens, and it's bent at that angle, 104 degrees. This is an example of a model of a water molecule, H2O. Ice is the solid state of water. Eventually this ice, you'll know, will melt and it'll be transformed into ice water. Eventually just water, the liquid state of water. The liquid state of matter, of water, is still just H2O. There has been no change in its molecular identity, but there has been a transformation called melting, and that's a physical change. Water at room temperature easily melts, and so we have our common and most important molecule we might consider in life is the water molecule, H2O. Now here is a can of soda pop. We're all familiar with that. It's made in a nice aluminum can. Aluminum is a recyclable element. It is a metal. And the aluminum, if you were to picture it as a substance in molecules, it would look something like this, where the red would be the aluminum atoms, all arranged in a nice array and the solid state of a metal. Let's take the can and pour some in to a beaker. What you hear is a familiar fizz. What is this fizz? Well, soda pop is mostly just water with a little coloring and flavor, and then there's the fizz. Its fizz comes from a saturated state of carbon dioxide gas. It's put in the pop under pressure, and then as we release it and pour it, it escapes as gas. So the fizz is actually little bubbles of carbon dioxide escaping when we pour it out into a warm glass. What is carbon dioxide? It likes to be a gas, but its formula is CO2. The black is carbon and the 2 reds are oxygen. You can see carbon is bonded to the 2 oxygens by a double bond. And it's a linear molecule. All the atoms are in a row. So carbon dioxide is an important gas. So the fizz that we hear from pop is actually carbon dioxide escaping from water. Carbon dioxide exists also as a solid. Let me show you some solid carbon dioxide. We call this dry ice. Just dump it out here because I'm not worried about it forming a liquid. Dry ice is very cold. It's about minus 110 degrees Fahrenheit, and we use it to keep ice cream cold or products frozen. I'm kind of smiling because ice cream really doesn't have ice in it at all, which we consider water. And dry ice isn't really ice at all because it's not water. As you're observing this is simply disappearing, little pieces of it are disappearing over time, going straight from the solid state to the vapor state, to the gaseous state. This is called sublimation. Sometimes we use dry ice to produce a fog because it's a temperature inversion right away. So I put a little dry ice in water, and you see how beautiful the dry ice is coming out of there as a vapor saturated with water kind of seems to overflow the beaker. Carbon dioxide in the atmosphere produces what we call the greenhouse effect. It actually might be a factor in global warming. But remember, when we talk about the gases in the atmosphere is made up mostly of two important gases, oxygen and nitrogen. Oxygen is simply a bimolecular diatomic element. The two atoms of oxygen are bound together by a double bond, and that's about 20% of the atmosphere is that. Nitrogen, the two atoms of nitrogen are bound together by a triple bond, very strongly bound, and it is a molecular element, and that's about 80% of the atmosphere is nitrogen. The other constituents of the air, of course, are some water vapor, this particular molecule, and carbon dioxide, which is a greenhouse gas. Remember this, though, photosynthesis from green plants are very important because what they will do is they will take carbon dioxide and the sunlight and they will make sugar and release oxygen back to the air. And we all need oxygen to breathe. Respiration, the opposite of photosynthesis. Okay? So let's think of some definitions that we have here. First important definition that I've tried to relay to you is chemistry is the study of matter and its transformations. These changes, they can be physical, such as ice melting, or they can be chemical, such as a match burning. But you might say, what is matter? Well, matter is given a simple definition. It's a substance that has mass and occupies space. Now, the word mass must be understood correctly. Mass is related to the quantity of the substance. It should be distinguished from the word weight. Mass is the quantity of substance. What is your mass? Is how many molecules are put together in you to make you. Weight is how much when you weigh the scales, is the Earth's attraction for your mass. It's interesting to note that if we were to go to the moon, you'd only weigh about 1/6 of what you weigh on Earth, but you'd have the same mass. So in general, mass is the more important quantity. But what about the other part of the definition? Occupies space. Well, it's easy to see that things like a solid, they occupy space. You can't put two of those together in the same place. But what about air? Air has mass and it occupies space. And sometimes because we can't see the gaseous state, we're not sure of this. And so I have a little demonstration to show you. This bottle is full of air. You can't see it, and you really can't weigh it because we're in a sea of air. But let's consider what happens. Let's just pour some water in this. It's not going in because the glass is already filled with air. And so all I have to do is let the air out by pulling this little plug here, and there goes the water. So that's just to make you understand that air occupies space and has mass, even though we cannot see it. Okay? Chemistry is an empirical science. Empirical is kind of a big word, but it means something very simple. It means that it uses a lot of measurement. And what we measure mostly in chemistry is mass. For that, we often use an analytical balance or just the simple scales that we can actually put something on and do a digital readout to say how much mass that is. Now, one of the things that if you want to get an idea of what a gram is, 1 penny weighs about 2.5 grams. So grams is a very small quantity of mass. Okay. Since chemistry is a science, we use the scientific method, observation, hypothesis, testing of a hypothesis, and formulating and making conclusions. We have laws and theories, all of which we will learn about in our journey through chemistry this semester. So again, I tell you, welcome to the world of chemistry, and the journey should be fascinating, and please try to be a keen observer. Look at the pictures in your textbook, use your imagination, and keep definitions in mind, because there's something about chemistry that it is a language. So welcome to this, our first session, as we join in our journey this semester, Introduction to Chemistry.